and welcome to a further maths walking talking mock. This is June 2015 and this is paper 1, which is the non-calculator paper. And okay, in case you haven't seen a further maths paper before, these are all the formulae that you get. So sphere, cone, they even give you sine rule and cosine rule and all that, which is really good. They even give you the quadratic equation and some trigonometric identities, which will definitely come in handy. Just in case I get stuck on any of these questions, I do have the mark scheme right over there on my laptop, so hopefully it won't be too bad. But further maths papers, they are difficult, okay? They're supposed to be difficult, that's the point in them. And remember that you only need to get 50% correct to get an A. Obviously, it'd be better if you got an A star or an A double star, but, you know, 50% to get an A. That's all you have to keep remembering. I'm also going to read a bit from the examiner's report as I do this as well, because I think that's quite interesting. So, for example, the first bit of the examiner's report says, most students were well prepared, and the gradual progression of difficulty of the questions meant that a number of students struggled with the more challenging geometry, algebra and trigonometry questions towards the end of the paper, but there were still some very good attempts at these questions with some elegant solutions. It also says there were also instances of good responses to questions being let down by some careless arithmetic, which my class wouldn't know anything about, of course. Topics that were done well: coordinate geometry, solving an inequality, algebraic ratio, matrix multiplication, simultaneous linear equations, change of subject. And topics which were found difficult: calculus applications, identifying coefficients in expansions, algebraic fractions, more difficult factorising, algebraic identities, defining a function and its domain, circle geometry proof, and trigonometric proof. Okay, so that's what we have to look forward to. So let's get started. Question 1. GH is a straight line. The coordinates of G are -2, 8. The midpoint of GH is 5, -3. Work out the coordinates of H. I'm going to do a quick sketch. G, H, and the midpoint. G is -2, 8. Midpoint is 5, -3. And we want this thing here. Obviously this sketch is awful because, as you can see, 5 is to the left of -2, which it clearly shouldn't be, but that's fine, it's still going to help me. So in terms of the x has increased from here to here by 7. Seeing as this is the midpoint, it's going to have to increase by 7 again, so that's going to be 12. And then in the y, 8 has decreased by 11 to get to -3, so I need to decrease it by another 11, so that would be -14. So 12 minus 14. Okay, that's 2 marks. Oh, multiple choice. A straight line with equation y equals mx plus c has gradient m and y-intercept c. We knew that anyway. Here are the equations of 4 straight lines. Circle the line that passes through 7, 2. Okay, so to test whether something passes through a point, I would have to substitute the x value and substitute the y value and check that both sides of the equation equal each other. So let's just test it for p. So if I put 2 in place of x, no, what am I saying? Put 7 in place of x and 2 in place of y, I'm going to get, let's jot it, 4, take away 28. Does that equal 5? No. Okay, so it's not p. Okay, let's try q. If I put 7 in place of x, that's 14, take away 4. And if I put 2 in place of y, I get 10. Okay, does 10 equal 14 take away 4? Yes. It says circle, right? Okay. Circle the line with gradient 2.5. Okay, right. Now they're not in the correct format, so I'm going to have to rearrange them. So P would be y equals 4x divided by 2, so 2x plus 2.5. R is going to be y equals 5 over 2x plus 2. Q is going to be y equals 2 over 5x minus 4 over 5. And S is going to be y equals minus a half x plus 5 over 4. Okay, so what am I looking for? 2.5. That's going to be R, isn't it? Yeah. Y-intercept's 2.5. Okay, I saw that somewhere. Yeah, there. P. Negative gradient. Which one has a negative gradient? S. S has a negative gradient. And perpendicular lines. So I need one to be the negative reciprocal of the other in terms of gradient. Okay, 2 and minus a half. 2 and minus half, they're negative reciprocals. So that's P and S. Let me check the mark scheme. Q, R, P, S, P and S. Q, R, P, S, P and S. That's good. I'm doing well so far. What was that? I can ignore that. Question 3. Solve this inequality. Okay, let's expand the bracket. By the way, this is going to annoy you about further maths. I'm warning you right now, this is going to annoy you. They give you lined paper for working out on, and that feels really wrong at first. Like, you just want blank paper. The lines are going to really annoy you. But it's good to get used to it, because in A-level maths they give you lined paper as well. Okay, so 6x plus 2. Like that. Okay, I'm going to add 4x to both sides. I'm going to take away 2 from both sides. And I'm going to divide by 10. Simple. That's another 2 marks. And number 4. The equation of a curve is y equals x squared minus 5x. Work out dy by dx. Okay, easy peasy. 2x minus 5. And I really should have written that there. 2 marks for that, that's good. P is a point on the curve. The tangent to the curve at P has gradient 1. Work out the coordinates of P. Okay, so remember, dy by dx gives you the gradient of the equation at any x coordinate. I mean, technically it gives you the gradient of the tangent to the curve at any x coordinate. So if the tangent to the curve at P has gradient 1, that means that 2x minus 5 must equal 1 when the x coordinate is the x coordinate of P. Okay? It doesn't depend on the y coordinate of P at all, it only depends on the x coordinate. So we're going to solve this. So I'm going to add 5 to both sides, and I'm going to divide by 2. So I know the x coordinate is 3. To work out the y coordinate, I'm going to have to use the y equation, because I know P lies on the curve. So if I put that x value into that y, it will give me the y value. So that's 3 squared, take away 5 times 3. 9 take away 15, which is minus 6. Number 5. In the expansion of that, the coefficient of x squared is 0. Work out the value of k. Okay, right, let's expand this bracket out. So I'm going to have x cubed plus kx squared minus 3x plus 2x squared plus 2kx minus 6. Okay, so the x squared coefficient is 0. So where are all the x squareds? That's an x squared. That's an x squared. And there's nothing else that's x squared. So I know that k and 2 must together equal 0, which means that k is going to have to equal minus 2. Work out the coefficient of x. Okay, so if k is minus 2, where are the x bits? Let me use a different colour. So the x bits I've got there and there. So the coefficient of x is going to be minus 3 plus 2k. And k is minus 2, so that's minus 3 plus 2 times minus 2, which is minus 3, take away 4, which is minus 7. Now, I remember the examiner's report said that that question was done badly. So let me just read what it says about it. Question 5, it says, neither part was well answered. In part A, most students chose to expand the brackets. Wait, that's what I did. What? Rather than just pick out the terms in x squared. Okay, so I suppose you could have just said, well, I know that the 2 times x squared is going to be an x squared, and the x times kx is going to be an x squared. So maybe they expected you to do that. This method is sound, but many students who chose it failed to then use the coefficients of the x squared terms to evaluate k. Okay, well, I didn't fail to do that. In part B, although the value of k obtained in part A could be used to follow through to work out the coefficient of x, there were still many numerical mistakes. Maybe with the minuses here, because I know that some of you guys struggle a little bit with the minuses, so maybe that's what they mean. Okay, question 6. A bag contains 5x red balls and 2x blue balls. The number of red balls is decreased by 20%. The number of blue balls is increased by 30%. There are now 35 more red balls than blue balls in the bag. Work out the value of x. I like this kind of question. So, if we start with 5x red balls and we decrease that by 20%, well, 20% of 5 is 1, so that's going to become 4x, isn't it? So 5x will become 4x. Blue balls is increased by 30%, so if I increase 2 by 30%, can't really do that. It's timesing by increased. Yeah, it's timesing by 1.3, isn't it? So it's 2x times 1.3, which is 2.6x. Okay, there are now 35 more red. Okay, so 4x compared to 2.6x, this has 35 more. So that means, how many more x's is this? 1.4x more. So 1.4x must equal 35. So x would be 35 divided by 1.4. And to make that division easier, I'm going to divide everything by 7. Okay, and then I'm going to times everything by 10. And I know that 50 divided by 2 is 25. So yes, the answer is 25. Number 7. We've got a cubic there, factorised, although not really factorised. A, B, C and D are positive integers. Work out the values of A, B, C and D. Okay, so basically it's saying factorise this cubic. So, as usual, we're going to start by guessing the first factor using the factor theorem. And it's got to be a factor of 98. 98 has loads of factors. That was quite mean. I suppose, you know what, A is going to be 3, isn't it? That's going to be 3, that's going to be 1, and that's going to be 1, because that's the only way we're going to times things together to make 3x cubed. I mean, I'm not saying that helps us or anything. Okay, so factors of 98. Let's write some down. Let's do a prime tree. 2 and 49, 7, 7. Oh, okay, it only has 2 factors. That's very good news. Okay, sorry, and 1, yeah, 1. And 14 is also a factor. So it has 4 factors. Let's try 7, okay? I've got a good feeling about 7. So I'm going to try 7. Oh, this is non-calculator. I should have tried 2 instead. Oh, I don't want to do this. Although, looking at that, that seems quite clearly not going to be 0. Would you say? Actually, no, this could be 0. Okay, what's 7 cubed? I have a feeling it's 243. That sounds about right. Let me do some working out. 49 times 7, 63, 28. Yeah, it's 343. Did I say 243? Okay, it's 343. Then I need to times that by 3. 9, 12, 1029. 98, 47, 147 times 7, 700, 280, 49, 980, 980, 1029. This better equal 0. Yes, it does. Yay. Okay. Right. So I tried 7 and it worked. That means that x minus 7 is a factor. Okay. So I only just realised that there's 2 D's. So, right, okay. If we've got 2 repeated, they're not 2 repeated numbers and a third number, and they have to times to make 98, it's going to have to be 2, 7, and 7, isn't it? That's the only thing that's going to work. Okay, so it's going to have to be that. You know what, I didn't even need to use the factor theorem. This prime decomposition actually told us the answer. Because look, it's 3 numbers that times to make 98. 2 of them are the same and 1 of them is different. So it has to be 2, 7, and 7. That's the only way it's gonna times to make 98. So actually, that was easier than I thought. So A is 3 I could expand this to check, but I don't want to. But I could. In an exam, I would. C is 2 and D is 7. Anyway, I can see by looking at the mark scheme that that's correct. So let me read the examiner's comment for this question. This question was a good discriminator. Well, by that they mean it's a question that sets apart like the people who are good and the people who aren't good, or the people who revised and the people who didn't. Although some students used... Well, I'm reading the wrong question. Right. Spotting the values of a and b from the first term of the expression, 3x cubed, and realising that c times d squared equals 98 was the most efficient way to tackle the question. Okay, so not the way that I started to tackle it. Many students tried to expand the brackets. Oh, that never even occurred to me. Oh. With varying degrees of success, and although this is a valid way to try and reach a solution, it frequently led to confusion, with some correct working often accompanied by incorrect answers. So, yeah. And how many marks? That was 3 marks. Let's do one more question, and then I'll go to another part. So, question 8. Algebraic fraction, lovely, this kind of thing you'd expect to see in normal maths, 9-to-1 maths. Okay, it's an expression rather than an equation, so let's see. We can't say, like, let's times both sides by x minus 6, because there isn't both sides here, there is only one side. It's an expression, not an equation, so you can't do that. If it equaled something, then yeah, you could times both sides by x minus 6, but this does not have 2 sides. So instead, we need to do a common denominator approach. It's quite obvious that the common denominator is going to be x plus 4x minus 6. So this fraction can stay exactly as it is. And this fraction will need to times the top and the bottom by x plus 4. Okay, and then I'll combine it into one fraction. Just realised they give you blank paper for this question instead of lines. Maybe it's because fractions are really annoying to draw on lines. Let's expand that bracket. I'm not going to expand the bottom, obviously. So that's going to make 2x minus 12. Okay, that's good, because I can see that that's going to factorise nicely. Because that's going to simplify. I can cross that and cross that. And what are we not going to do? We are not going to say, I'll cancel that 2 with that 4 to make that a 2. You're not going to do that because 2 is not a factor of the denominator because of this x. Okay, if that was 2x, then that would be fine. You could cancel the 2 with that 2 and that 2. That would be okay. But you can't just cancel the 2 with the 4, okay, because the x has to be involved as well. So that's our final answer. I think I saw it said that algebraic fractions was done... Oh no, this question apparently was done well, according to the examiner's report. Okay, I'll stop there and I'll see you in part 2.